market. Few years ago, we did not really have KPI in the line. So we, as inspection, we were used as a filter at the end of the line to check that there was no defect. Then we started seeing some offline KPI with some drill down analysis where we could analyze and find the root cause of the defects. Then, little by little, we implemented some inline KPI, such as live dashboard. We can see today a lot of dashboards at our customer on top of the production line, so that our customer can see in any visitor in the SMT line can see the current status of the line.
Yes.
And the next step right now is to get notification in advance. So we can think about embedded SPC that would, for example, warn when the process is drifting. So we can have this for SPI, for AY. And we can also have this for a placement machine before we run out of components. We can be warned.
Yes.
So,
yes,
yeah.
okay, that's quite common. But I guess to be able to pick up a lot of that information, Francois, they need a system to be able to pull it off of a machine, because there's a lot of legacy equipment still out there.
Yes, correct. And there's different levels of layers of software in a typical factory. So obviously you have the machine level software, which is typically very, very integrated with the machine. Obviously it comes from the people who make the machine, so they can get to a very high level of data accuracy and control. And then you have a shop floor control, which is the next level, and then eventually you have your MES and ERP and enterprise level systems. Right. But at each level it's possible to do different types of anomaly detection, right? Looking again at a different angle of the whole process. At the level we're at, where we're doing software for shop floor control, we can look at multiple machines from multiple vendors and try to make correlations and detect anomalies throughout multiple machines and multiple brands of machines. That's typically the level we can participate in. Yes.
Absolutely. And I guess you're fairly used to integrating these systems, Axel. I mean, yep. Especially at the SPI printer level, that type of thing, but also at the pick and place correction level as well. Yes. I mean, really, the way you're looking now, you're actually going a step further now and going towards the AI level to try and be a virtual assist, as it were, to customers. Yeah.
Yes, that's correct. So we figured out, or when you want to establish a working AI in the production, you have to detect the anomalies and you have to filter them out. Because at the end of the day, when we want to control a process, we want to detect process shift, react on process shift, and not on anomalies. An anomaly, simple case, could be a piece of plastic on a board, and you detect it, and you don't want to mess up your parameter that you react on this random effect. An anomaly could be a wrong setup in a printer where someone forgot to put the underboard support inside, and you don't want to change now the printer parameters due to a not trained operator, for example, or missing traceability on the printer. So it's very important to detect these anomalies and to filter the data you grab from SPI, from AOI, and to drill down to real process data you can work with. And then the anomalies, you have to react on it, but in a way that you send messages to the users, to the operators, to the line engineers. But real process control, you have to filter them out. Yep.
Excellent. Now, there's 4 of us on this panel, 5 if you include me, so to get through all these questions, we're all going to have to keep our answers relatively short, if you don't mind. Michael, I'm going to move on to you quickly just on that first question, and that is, how can we respond better to these anomalies more quickly?
The response time is a measure of understanding the problem.
Right.
And where we see data being derived through whatever mechanism from different machines, they all have their own perspective on things. So they may know very well what they're doing, what they've been programmed to do, but they lack the context of what's happening in other areas, in other processes. So to empower the kind of intelligence, if you like, behind the algorithms to adjust production to improve things, we need to provide that context. so that they can understand, okay, there may be 10 different causes of this drift. Which one is it? Because the actions associated with those will be completely different. And just to say you need to take an action may be misleading if that context has not been established correctly. So it's not just a matter of obtaining the raw data and trying to process it the best you can. It's actually build the intelligence using the product, the design of that product, the line configurations, the settings on the machine, who is doing what, even what happened to the product before it got to this line.
Right.
So the more context you have at the factory level, the better the results come from the analysis of the data.
Right, and if you're monitoring that process over time, then you're building up that trend analysis so you can get a more accurate.
This is where insights come in, yeah, because you can, certainly on the level of control of the shop floor, you're making immediate decisions.
Yeah.
But looking at historical deep dive data, you see the patterns that are going to show you that opportunity to take action based on things that you wouldn't have ordinarily noticed.
Yeah, okay. So I'll move on to my second question, and I'll stick on you at the moment for Michael, which is what strategies can we implement to enhance the scalability and flexibility of process control software to accommodate changes in manufacturing requirements and technological advancements?
That's a long question.
It's a long question, isn't it? I could cut it down a bit.
No, but the fact is that things change. And as things change, you may, for example, get a machine that suddenly starts speaking a new language. You may have a new requirement for analysis that we've discovered or invented. I mean, we are always trying to invent new ways of creating value from data. So how do you then go back and say, well, actually, the data that I thought I needed, now I need a little bit more. Or this data isn't really suitable for this problem at all. So one of the ways we've approached this from the standards point of view with Connected Factory Exchange, or CFX, is to try and predict what data is going to be useful and putting that into this single language.
Right.
So are we chasing an achievable goal? I think there's an element of that, but what we should make sure is that we avoid the unexpected changes. As long as we have a standard that people sign up to and we understand what the capabilities are through the qualification process that CFX has, then we can understand what the individual capabilities of machine vendors are and, of course, solution providers.
Right.
So that gives you then that assurance that even though things are changing, expanding, you know that everything is going to work.
Okay. Francois, have you anything to add to that on that topic?
Yeah, sure. We see similar to what Michael has been saying. I think what's very important beyond the technology is that the different companies involved in this ecosystem need to work together more closely, right? Yes. Standardization is a very important step in that direction, but actually, machine vendors talking to each other, software vendors working more closely, because this does not happen in a vacuum, right? It's got to be everybody has a piece of the solution, and we have to work together very openly to do this. Yeah.
Well, you're right. I mean, standards always follow the technology, and they're usually quite a few years behind it. I think what's been happening recently has been that IPC, thank goodness, with some of the people that are involved in it, have been actually quite fast in following the technology. But it's evolving so fast at the moment that it's pretty hard to keep up. Yes, it really is. I'm going to move on to my next question, and I'll give it to you, Axel, here, and that is, are there ways to streamline and automate decision-making within the software, such as using machine learning algorithms for predictive maintenance or quality control?
Yeah, this is already in place. So today's machines have already AI implemented. That means, first of all, AI is used for denoising algorithms to make the measurement more efficient. And on the other hand, it's used in the judgment of defects, especially if it's 2D, where we do not measure. So there's room for false decisions. And there we utilize deep learning to create cases, decision cases, which support the user later to come faster to a conclusion about a defect or to get more security in the judgment for the defects.
Okay. Thank you. Alexis, do you have something to add on that?
You're right. The AI main battle for the last few years have been to fight against the false calls. So where the deep learning really helps today is that instead of calling the operator to review each defect detected by algorithm-based, then we can call a deep learning network and say, hey, is it a real call? Is it a false call? So we optimize and we avoid human errors like that. One main concern about that is that we need the market to start trusting the AI. And there's a real, this is a global move that we all need to do together, I believe. And this can be done only if the customer keep the control of the data that will be used to feed the deep learning models.
Right.
So, and then we will implement it step by step. It can only be like that, first in kind of simulation mode or listening mode, whatever we call it. And then when the customer is convinced that the AI is more reliable than the human, then we can move on in production.
Well, I think that's quite common to all new technologies. You know, whether it's smart factory or whether it's you know, in this case AI. You need to have somebody in the factory that's the champion of it, if you like, and make sure there's buy-in amongst the senior management at least for this type of new technology, and then it basically starts to gather strength and people get trust in it. I know you're dying to say something, Michael, so let's go.
You know, we used to rely on people in manufacturing. I mean, people in manufacturing of my generation, they learned I didn't, but they learned so much about the processes they were involved in. And over the years, we've begun to trust machine vendors to embed that know-how within their machines. We've learned to trust software providers like Francois and ourselves, where we are beginning to automate through software, automate through the operation of machines, replacing that dependency on skills. So what you're saying is absolutely right, that we now need to begin to trust not just the decisions that are being made, but this whole process of learning not to depend on people's judgment, but to rely on the software to be able to provide that assistance that we need. So AI is not going to run the factory, but AI is going to suggest ways in which we can improve the factory. Some of those will be automated, for example, within an MES system, ordering the next material or adjusting parameters on machines through machine learning. So as we get more and more trust, it will become more and more automated. But ultimately, somebody will be in control. But we will not be dependent on a deep dive skill level of that person. They will be people who manage and understand the flow of the factory rather than the old-fashioned skills that we had before. And this makes manufacturing more attractive, more sexier, more interesting for people to come into as younger people in the industry.
Yeah, absolutely. No, I think it becomes, and the automation becomes an assist to the operators. Exactly. You know, exactly. So that's good.
I disagree a little bit. I disagree a little bit. So we have AI solutions, so I also know the risks, and there are also always exceptional cases. And sometimes these cases are hurting. So we cannot make the old-fashioned expert redundant. So there must some instance to control the AI to detect these exceptional cases. Because when we detect them too late, then it could cause a lot of waste and money losses and so on. So I really rely on AI, and I like this development, and I really think it will improve a lot, but we cannot leave the systems 100% alone. And we have to sensitize the users as well for this proposal.
Yeah, I agree. I think we don't disagree. I think as a general aim, we want to eliminate the dependency on them, but that doesn't mean eliminate them entirely, because things will need to happen. But I would suggest that, you know, how long have we been making circuit boards? It's been so long. What's the chances that we're going to see something that's genuinely new that nobody ever thought of before? It does happen. So
But maybe we forgot something in our model.
Well, I would hope you're covering almost everything. Your software is excellent. So, but yeah, it has to be the exception. So we need to manage the exceptions. That's absolutely right. But in general, day-to-day manufacturing, we need to automate as much as possible, and that know-how is in the software of solutions and machines. So I see that as a great step forward for manufacturing that we've seen due to the introduction of AI, like you have.
I think it is, but you know, I think there are also some other concerns out there, which we're going to come into later, one of the later questions here. But for now, I think we've answered that one. Unless, Francois, you've got anything to add. Did you already answer that one? I think you did. You're good. Okay. So, so let's move on to question 4, which is basically how can we assure the security and integrity of our processes, of our process control software to protect sensitive manufacturing data and prevent unauthorized access or cyber attacks. Now, 2 weeks ago in the UK, we had an AI conference which was put together at a government level, and it brought in governments from the US, from China, the European Union, and everybody to discuss the very real issue of security around the topic of AI, because you know there's always a way to be able to control AI using standards, etc. But there's always going to be a bad actor. How do you avoid that? And it really is a big question. I don't think anybody's really answered. Do you have a view in that, Francois?
Sure. Security is definitely becoming a major concern for all manufacturers in any industry, right? For all the reasons that we've seen. Some factories can be shut down for weeks if they, if the wrong people get into the systems. But in the past, the factory environment was fairly closed, right? There was not much connection to the outside world. I think technologies like AI are creating more of a need for outside access, through the cloud. If it's only to access machine learning models and things like that, to train the models, bring them back into the factory. But these create opportunities for, again, the wrong people to access the manufacturing system somehow. So security has to be extremely tight. The good news is manufacturing is not the only industry dealing with that. Banks also have to deal with that, and governments and defense companies. So technologies exist, they have to be adapted to our industry and they have to be implemented. It's taking a bit of time, but I think over time people will be very much more comfortable because security will be there, will be proven, and people will be comfortable with that.
Yeah. I mean, Francois is absolutely right, Michael, that we've got, for example, some of the big contract manufacturers that are doing defense and things like that, very sensitive manufacturing. They've still got to take advantage of all the automation advances that we're going to make over the next couple of years. But they've got to be able to do it safely. So what's your view on the security aspect?
There are two real questions. The first is how do you secure the interface to the machines? Because you have remote access, you can change parameters, make machines do something a little bit different, which normally is a good thing, sometimes could be a bad thing if the wrong person gets in. So I'm going to mention the C word again, CFX. When we developed CFX through IPC, we encrypt the data end to end. Mm-hmm. So this is using the strongest encryption available, so that even through the internet on the other side of the planet, nobody can intercept that data. So any machine control implemented through CFX is absolutely and totally secure. Right. That's the first part. The second part, governments are now asking, customers are now asking to share more information about manufacturing because they want to establish trust, or they want to find out how much CO2 was emitted through the creation of a product. So manufacturers are actually going the wrong way. They're being asked to share more data openly in ways that create a risk for their intellectual property and certainly expose their privacy issues. Who are my suppliers? Where did I get that from? What machines do I have, etc. So what we're working on in another standard with IPC for sustainability is how can we create a digital credential that represents a provable situation in manufacturing, like the CO2 that was emitted, for example. How can we provide that digital proof in the form of a credential which can then be shared with the customer, with governments, to comply with reporting legislation, those kinds of things. Right. So without disclosing the private information, because we don't want any bad actor to infiltrate that data and be able to learn about our product. Even the design data is
Well, that's
subject
right,
to
because
that.
I mean, what's happening now, if you look at any shareholder reports or that for these companies, they all look at their ESG and sustainability data, and it's important. So companies are paying a lot of attention to this because it's going to directly impact their shareholder value.
This is it. So this is creating a real conundrum for manufacturers. How do we share facts without disclosing data? So there is a World Wide Web consortium standard called verifiable credentials that we are now populating automatically from manufacturing data to show that we can prove trust. We can show cybersecurity adherence and the business process around that. We can provide the sustainability credentials, all of the things that people need to share, but they're not sharing the raw data. They're not sharing anything that's IP protected. They're simply sharing these digital credentials that prove the manufacturer did their job. And all of the data is retained in the secure environment on site.
Okay.
So this is really looking toward the elimination of opportunity for bad actors.
That's encouraging, put it that way. Axel, how is Koyoung approaching this problem?
So luckily, in most cases, we are embedded into an IT security system of our customers. So the customer IT is taking care. And for example, the AIs we are using to control processes like optimizing printer parameters are isolated single PCs which are inside the SPI, running totally autonomous, no connection to the outside world. So these systems are safe. Regarding the server applications, so in most cases these is in the responsibility of the IT systems, IT administrators, and we cannot do a lot of things about this because they making the rules and they making the standards and requirements and the environment for our systems.
Okay, so you're very much, they have control of the software security environment. Okay, moving on to my last question. We're starting to run out of time, so we need to keep our answers a little bit short. And I'll start with you, Alexis, on the end there. How can we? Oh, sorry, I beg your pardon. What measures can we take to optimize the user interface and user experience of our process control software, making it more intuitive and user-friendly for operators and engineers on the shop floor?
Well, the first thing is to listen to the users. So we really need to get the user expectation. They are different from the region over the world. They are different from the user profile, from the operator to the process engineer to the line manager. So what is important is to provide the right meaningful and actionable information in the screen in live. So let's say that Micronic strategy has been to use beta testers to really collect the user's feeling, needs. And then we also use some UX designers to be sure that we always show the right information. Offline, as I mentioned before, the offline SPC, where you can dig in, this is more expert. But on the line, you need to have the right information in one graph.
Okay, great. Thank you for that. Michael?
Alexio is absolutely right. When it comes to operators doing something, the way I see it is that me, as a complete idiot, could go into a factory and do some work, maybe on your machine, maybe on your machine, and I would do it perfectly well. How? Because I would follow instructions that appear. Now, those instructions in the past have been quite difficult to create because, as you said, you need to understand the user, know what they're doing. But this is not the first time we've made a circuit board. This is not the first time we've done this. How can we learn from the past and apply that experience? What we would like to do is to compose the user interface in a way that is going to match precisely what instruction is needed and reference information needed, and carry the information as a result of what's been done to provide that back as traceability, measurements, control, etc.
Yeah.
But we need to compose that easily. We don't want to have to resort to coding or do some kind of weird programming and assessment. So driving that using the design data itself, understanding what the actual components within the design are, representing those in 3 dimensions, for example, but doing that in a way that's automated, following the simple composure of what we need, based on that experience that's built into the tools. So that's how we achieve what you want to do. But in any environment, it could be assembly, it could be logistics, it could be anything you like. But that composability, doing it so easily, is the key.
Absolutely, an easy to use GUI interface that's easy to program.
Exactly.
Yeah. You agree, Francois?
Yes, I do agree. And as I mentioned in my early comment, there's many layers of software in the factory, right? And somehow this could get confusing. There's more and more software from more and more different vendors, and somehow we're trying to make the operator's life easier, right? So I think having open architectures, having a lot of integration, and trying to streamline the user interface, and even take away as much as possible, so he only has very simple instructions and so on, right? And AI can help with that, but the design of very intelligent user interface is also important. One example is in the past, if you had to troubleshoot something, you'd go to a user manual, right, and then try to find the right page and all that. Now you use ChatGPT, you just type your question and you get the answer right away in your language, and then you can ask more questions, and it's a lot easier to use, right? The information has to be accessible in a very simple way. Yeah.
Okay. All right, last word to you, Alex, but we've got about 30 seconds.
Okay, I agree with all comments. But it's right. So you have to catch the information with one view, because we are flooded with information in these days. And as easier the operator can catch the information and get easy access to solution, like Francois said, that we have the right advice for process recovery for him, then it's a perfect world.
Absolutely, great. Well, I think we got through it pretty well. Some good answers there, and I want to thank our audience, our panel, very much for taking part. So thank you very much to Alexei Ray from the Micronic, of course Michael Ford from Aegis, Francois Manette from Cogiscan, and of course Axel Lindlof from Co-Young. So thank you very much, ladies and gentlemen, and thank you to our audience for watching. Coming up after the break, we are going to be coming back with our second panel discussion of the day on ESG and sustainability in electronics manufacturing.